All right, so as I just told you a little while ago, we can factor polynomial functions, and whatever the degree is, that's how many total factors it would have. Not all of them will be real, but if they're imaginary, they come in pairs. So it says here, consider this function. Right, k of x is a product of linear and irreducible quadratic factors. So we're only going to focus on the real, and then we'll leave the imaginary as a quadratic factor instead. So I want to look at the picture here. Remember, we have 5 possible zeros. And we could go through the other things we've learned, like what are the rational zeros and all that. But I'm just going to look at the graph. It looks like -3 is a 0, -2 is a 0, and this value here, 1, 2, 3, 4, those are zeros. So that we know that k of x has the factors x plus 3, x plus 2, and then x minus 4, because the signs always switch here. Now, that's how many zeros? 4. So there's 2 left over. There's a quadratic left over. Now, here's how you find out what it is. You simplify by using synthetic. So determine the quadratic. We're going to use our synthetic here. So I'm going to start off with, up here, this in synthetic. So we have 1, 1, -13, -23, -14, and -24. Now, each one of these zeros should work, so I'm going to divide by -3. It does not matter the order I go in. So when I divide this through, I better get 0 here, because we're saying it's a factor. So I get -3, that's -2, that's going to be +6, which is -7, multiply +21, so I got -2. Multiply, I get +6, that's -8, -8, +24, 0 is my remainder. That's a good thing. So since it's a factor, we could continue on from right here. Now I want to take my next 0, which my next 0 is going to be -2. And so I want to divide this by -2. So 1 times -2 is -2. That gives me -4. Multiply, I get +8. This leaves us with 1. Multiply, -2. This is -4 again. Multiply, 8. We got 0, which is a remainder. That's good. So we can keep simplifying this equation. I've got one more to do here, and it's with the factor of 4. So I'm going to divide in 4 into this. And so I have 1. I have to draw this line under there. And that gives me 4. That's 0. 0 times 4 is 0. Leaves me with 1, 4, and 0 is my remainder. Again, it should have been that way the whole time. Now, what we could fill in is we started off with x to the 5th, which means this first one was x to the 4th, which this is x to the 3rd. This is x squared. This is our x, and that's a term without it. Our last factor would be x squared plus 1. That's our last factor. So I can come up here and put x squared plus 1. That right there is our answer. And we got that by synthetic division. That's the product of linear and irreducible quadratic factors. Linear, 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 irreducible quadratic. So let's try this now. So the same thing, but now as a product of linear factors. So let me pull over the answer. So now we talk about how do we factor this. So this is kind of like the difference of squares, except it's a sum of squares, which is not a real value. But how you could rewrite this is to a difference of squares. Now difference means subtraction. If we rewrote it this way, if we said that this is equal to x squared minus -1 squared. Now here's the deal. -1 squared, so 2 negatives. And really, this is kind of bad math, because if you look at it, that squared would become positive. So I'm kind of jumping a step, and I want you to know the way you write this is where you put your I in. Remember how I squared is equal to -1? Really what you're doing is saying it's 1 minus I squared. So that would be the same thing as 1 minus -1 squared. Okay, so we really write it this way. Now I have it as difference of squares, and you'd say that this is x plus I and x minus I. That's how you get the imaginary. So when we come into class, I'll talk a little bit more about this, but that's how you would actually get this into imaginary terms, is you would say this is x plus 3. That part was easy. X plus 2, that was easy from our graph. This one was also easy. This part is a tricky, is learning how to you put in a negative and change these to i's, and that's how you come up with your terms. So we'd have x plus I and x minus I. Remember, anytime you have an imaginary, you'd always have a pair with it, and so this would actually be your solution there. Okay, now let's talk about all the zeros. Okay, we already had that negative 3 was a 0. We already had that negative 2 is a 0, and we already had that 4 was a 0. Is that correct? Yes, we already had those. Now what we do is we fill in the imaginary. We also know that this would be negative I, and this one would be positive I. So you'd have negative I and positive I, or you could just say plus or minus I. These would be your zeros here. All right, you can go ahead and try this one.